So what we're going to do here is Unit 4, Lesson 4, and you should have class book page 146 and 147 in front of you so you can kind of do it along with me. The overarching lesson here is on multiplication comparisons, and as we are doing throughout this entire unit, it's getting us ready in our mindset to be able to problem solve and to take care of word problems. So I have a little ditty up here. Rashmi picked 15 apples while her little brother picked 3 apples. So I have this question for you. What two quantities are we comparing? And that's a pretty easy one, right? It's the number of apples that Rashmi picked and the number of apples that her little brother picked, Eli picked. And there's several different ways we can compare these numbers. You can use multiplication to describe the greater amount in terms of the lesser amount. And we know, knowing 15 and 3 and how they're related with multiplication, we would say that Rashmi picked 5 times as many apples as Eli. So how do you know it's 5 times as many? Well, we know that 3 times 5 equals 15. So let me draw a little picture here. We call these comparison bars, and we're going to do it with another little number on 146, but I wanted to do this with the apple picking first. So if I have what Eli has, 1 bar equals how many apples he picked. Okay? And then we have Rashmi picked 5 times that amount. So she picked 1, 2, 3, 4, 5. The hope is that they'll be equal. I'm not a very good drawer. I apologize. So you would say that Rashmi picked 5 times as many apples as Eli. Let's do another. We're going to be comparing a lot of numbers today with multiplication. So I hope that you will start to see that when we do a couple more examples. So looking on page 146, you see that to prepare for a family gathering, I'm right here, Sarah and Ryan made soup. Sarah made 2 quarts and Ryan made 6 quarts. You can compare these amounts using multiplication and division. We're going to let R equal the number of quarts Ryan made, and we're going to let S equal the number of quarts Sarah made. So here's those comparison bars again, and we're going to be looking at them, and we're looking at 6 and 2. Ryan made 3 times as many, there's that phrase again, quarts as Sarah. So if I was using R equals 3 times S, R equals, these are all the same. This is the same sentence, this is the same sentence. Or if we're talking about the inverse operation, it would look like that. S equals R divided by 3. Because we know, look at the boxes, 1, 2, 3. There's 3 times as many squares for Ryan to Sarah's 1. So let's try this with another example. Natasha made 12 quarts of soup. Manuel made 3 quarts of soup. So let's draw comparison bars to show the amount of soup each person made. So if I have Manuel, and he only made 3 quarts of soup, and then I have Natasha, who made 12 quarts. So I know my multiplication facts. I know that I need to do 1, 2, 3, 4 bars because 3 times 4 equals 12 quarts. So who made 4 times as many quarts? Well, Natasha made 4 times as many quarts as Manuel. So if I was writing a multiplication equation that compares the amounts, I'm going to just use their first initials, M and N. I would write an equation that says N equals 4 times M. 4 times the amount of Manuel. You could also do N equals 4 dot M. Now, if I was doing a division equation, I would say Manuel equals Natasha divided by 4. Because Natasha is 12. 12 divided by 4 is going to give me the 3 that I need. Multiplication is the putting together of equal groups. How can this idea be used to explain why a times as many comparing situation is multiplication? I'm going to have you pause right here and think about it and jot down an idea. So hopefully you had some time to think about it, but you had 3 examples to look at because you have Rashmi's example, you have Ryan and Sarah's example, and you have Natasha and Manuel's example. How can this idea that multiplication is the putting together of equal groups, so it's that 3 4 times, it's the 2 3 times, it's the 3 5 times. How is that idea going to help us to explain why times as many is a comparing situation is multiplication? So if you hear times as many, you know that there's going to be a multiplication situation going on. Well, it's because that greater quantity, Natasha's 12 quarts, is repeated groups of the smaller quantity. It's 4 repeated groups of Manuel's 3 smaller quantity of 3 quarts. It's Ryan's 3 groups of Sarah's 1 group of 2. It's the repeated, how many times you repeat that smaller quantity. Okay, so we're going to try this some more with number 6, 7, 8, and 9. If you need to draw a model, you can draw a model, but I'm hoping that the comparison bars that I'm about to draw for you might help you out a little bit. But there are 24 students in the science club, and there's 2 times as many students in the drama club. So if I have science club and the drama club, how many students are in the drama club is what it wants to know. So it says 24 students are in the science club. There's 2 times that as many students in the drama club. So I can draw my comparison bar chart. This first bar is going to be equal to 24 students. Well, if there's 2 times as many students in the drama club, I'm going to have 2 bars that represent that. If I were to write an equation with that, I would say that drama club equals 2 times 24, which equals 48 students. I took that bigger number and repeated it to get 2 times to get the larger number. So there's 180 pennies, looking at number 7. There's 180 pennies in Miguel's coin collection. How many? And that is 5 times as many as the number of quarters in his coin collection. How many quarters does Miguel have? So I have to take 180 pennies equals 5 times the quarters that he has. So if I divide 180 by 5, I have 36 quarters. Let me read it again. There are 180 pennies in Miguel's coin collection. That is 5 times as many as the number of quarters in his collection. So that is, this is right here tells me that's equal 5 times as many as the number of quarters. So 5 times his quarters. Hopefully you're starting to see how to set these equations up. Number 8. Fred has lost 72 football cards and Scott has 6 football cards. How many times as many football cards does Fred have as Scott? So if you were setting this up, you might set it up as, the best way that I can set up number 8 for you is Fred has 72 football cards and Scott has 6 football cards. How many times as many football cards does Fred have as Scott? Well, if I do a division problem where I divide up Fred by what Scott has, I'm going to find out how many times more that is. So I might set up my equation as 72 divided by 6 equals what, how many times or how many cards. So there's 12 times as many cards. How many times as many? So Scott, because we know in a division problem that whatever is our divisor and our dividend are multiplied to get our dividend. I hope I said that right. It's very late on Friday afternoon, so hopefully I said that right. Let's look at number 9. Audrey has 1,263 centimeters of fabric, and that is 3 times as much fabric as she needs to make some curtains. How many centimeters of fabric does Audrey need to make the curtains? Well, when I'm reading this, I hear Audrey has this really big number, and that is 3 times as much fabric as she needs to make some curtains. So I'm hearing equals 1,263, and it's 3 times something. 3 times as much fabric as she needs. How many centimeters of fabric does Audrey need to make the curtains? So we need to find out what one curtain would figure out. So we would do 1,263 divided by 3. And we would get 421. So she needs 421 centimeters worth of fabric. Now I don't want you to freak out about this because we will be spending more time on it tomorrow. Fill out your form and see how you can reflect on some of these words. I know some of this is not new. You've been doing as many as and as times as much in your past, but I'm just trying to equip you with some more tools to problem solve word problems. See you tomorrow.